I'm running a multi-agent Frontend CAD reference flow. Here, these are the different agents that has been integrated. First, it will create an IP structure or SOC structure. Then it will create the environment, the entire setup. Then it will run the RTL parsing. Also, it can run CDC analysis, Lint analysis. It can do CDC advising also, and also it can generate formal verification and bunch of other agents. So just to show how a simple prompt can create the whole thing, so I had ran it up front. So let me do it here. So what I'll do, I'll first set the workspace here, then I'll set the LLM because it supports multi-LLM. So I am starting Cloud Opus. It will set code. So I'll start a new conversation. By the way, so workspace is a directory. You can see this is the directory where everything will be created. So I have selected the given workspace. I will start a new conversation in this workspace. Okay, so I will put a prompt like create a soft IP counter with technology 7 nanometer configuration. Since it supports multiple configuration for a given IP, so we can specify the name of the configuration. For this IP, you generate a Verilog 8-bit counter, and after generating, place everything in the appropriate structure, create setup and everything, and then parse the generated RTL if all goes well, and then do a lint. I am using a free tool called Verilator for the lint. So this is what I have given in the prompt. Let's see how it goes. This will, I should have selected Cloud Opus. Let me select again. I have selected. Now I'll give again the prompt because I want to run it. Claude Llama is very slow. Okay, it has generated. Now you can see the execution plan for this. This is multi-agent, so it's cross-agent execution plan. Based upon the agent, one agent's output, the other agent gets invoked appropriately. So it will first create the SIP structure, soft IP structure. The structure name is called counter here, you can see. And then it will generate the Verilog for this one. So generate Verilog module for this counter, place in the directory called src RTL Verilog. I'll show you that it gets actually placed. Then it sets the technology. As I said, it supports multiple technologies, multiple configuration. It is setting the technology to 7 nanometer. Then it is set technology node to 7 nanometer. Then set design configuration name to CNT8 because you can change it to any other configuration if you want. Then the top module name, based upon the generated RTL, it will extract the top module name, and the top module name will be filled up. You see, will be auto detected from the generated RTL during execution. And then after that, it will create all the setup. For example, setting up the tool, setting up the license file, setting up the path. So it will do all the necessary setup, and then it will create the file list. Based all the Verilog file which has been placed, those are put into a file list. And then it also creates a design configuration because I will be running this setup for a given design configuration, which is that technology node 7 nanometer, and CNT is the dot configuration. After this, once all these are done, it will run the Verilog RTL parsing flow, which is inbuilt of EDA utils called NVL Verilog parser. So for this, it will generate the file list, it will generate the make files, different make file for compilation, elaboration. So then it will run NVL compile, NVL elaboration for the given design config file which has been populated. Similarly, it will also generate file list for linting, make file for linting, then Verilator compile, Verilator elaboration, and then it will run. So let me run this entire pipeline and see how it goes. As I said, I will be using Opus, Anthropic. So it has completed everything in one shot. Now, up to not everything, it has created up to the configuration. Now it is running NVL, it has run it. Now it is running Verilator Lint. So you can see all the steps have been completed successfully. Just to give you a glimpse what is happening behind the scene. So these are the different agents I am running. So this is the agent which is for formal verification. So EU formal verification agent Gen AI, which basically for a given specification, it should be able to generate the properties. It has its own bit learning capabilities, feedback taking, knowledge base, everything is embedded into it. This one is basically create structure. So whenever we run the create structure, this agent is being executed. See, yeah. So create structure agent, which creates the IP structure or the SOC structure, different directories as per your design environment, as per your methodology. Then this one is a setup creation agent. So if you see here, so we ran the setup creation, it ran everything there, including this, as I said, file list generation, tool path setting, and everything it will be done. This one is the forgotten what was the agent. Yeah, this is the RTL parsing agent. So after generating RTL, creating setup, file list, and all the stuff, this agent gets executed. And here also you'll see it got executed, and you see this. This is the elaboration, and you can see this agent is running all the steps, make file generation, running the tool here. Now this is the top level orchestrator. Here this from top level we run the flow. So you will find that this is the overall, you can say, the top level manager also. No, this is the lint, sorry, this is the lint one. This is CDC. This is the one for top level orchestrating. It also shows that all the pipeline has been executed. You create, after that Frontend CAD generate Verilog, then it has set the technology, design configuration, top module name in this config file, and then file list generation. Here is the config generation, then running RTL parser, then RTL Lint. Now all the logs have been kept here. We can see the log. Now if you want to see what it created, you will be able to see that file called counter, because this is the IP name that we have given. It was created, and this is the different structure. For example, these are different configuration file, documentations, environment. So you can see it has done. Maybe so it has created the project variables. Then it has created this Edautils root, because as I told, I am running my own tools. So this tool setup has been done. License file accordingly, it can also set up any other tool as once you configure it. Now you can see the src RTL, because it has kept the file here. Verilog it generated counter.b. So this is the file that it has created. Now you can also see that this file should be listed in my file list. So this has been listed here. Now when it ran all the tool, the output will be kept here. The output. Now it runs in file list generation. It ran the Verilog parser, my own parser, that's why I kept it here. Then static checks for with Verilator. Let's see. So it will keep all the flattened file list, because you may have sub IP dependencies, everything will be sorted out. So the flattened file list contains the actual path. If you have sub IP dependencies, everything will be listed here, all the Verilog files. Now so it has created this JSON file with the compilation error and warning summary, which generally referred for the dashboard population. You can see the Verilog has been parsed here successfully. This is the Verilog file list which has parsed. This is the file which was listed there in the Verilog file list. So this is the elaboration one. Now similarly, Verilator is also run. You should be able to see the static checks, Verilator, and log, compile, log, and run. So this is all about. Now let's see if we can generate the formal verification specification for this or not. So now I ran this. So this is the prompt I have used. So let me give a prompt here now. Generate formal verification properties from the attached design specification. This is tool independent. I don't need anything. So let it generate that. Let me see. So this is one I2C design specification which is freely available. That's what is going on here. This is the formal verification agent. Okay. Generating formal verification properties. Okay. It will take some time, as you can understand. We'll read the entire design specification, try to understand the architecture, and from the architecture it will do it. It has generated the properties. Now you can see the result. So the file is big, it won't be able to fit everything here. So it has put a snapshot of the property, but the complete package it has kept into this download report. So now what we can do is that it also mentions that these are the files it has generated in the workspace area. Now let's see what was there into the okay. So in the console log it says that okay, just now it has created, it says that generated download package is this one. Let me see what does it contain. I can also download it here if you want, so let me download it here itself. Okay, so it has, let me keep it into the design package. So keep, let me open this one. What does it contain? So it says it created the properties and also it created the run ticket. Let me see how the file looks like. So you can see the property is generated by it. I2C formal verification properties, and okay, see, based on the architecture it has created all the properties here. The I2C architecture as which I have given here is this one. Let me see if I can show it to you. It was there in the download. Let me see. It should again come back. Anyway, so can I get into my download folder and see? Trying to yeah, this is the spec which I have uploaded. Okay, thank you.